Okay, we are now on part 2 of the linear review sheet, which is going to be graphing lines in slope-intercept form. So we have one example here. It's y equals 2/3 x minus 4. And in order to graph our line, we need to first determine the slope and the y-intercept. So I always like to write them down so we know what they are as a visual. Remember, our slope is always the m, which is the number in front of the m. So in this case, our slope is 2/3. And then our b value is that number out here by itself. So our b value is -4, but remember our y-intercept always has to be written as a point. So it is the point 0, -4. So when we go to graph this, we always start with our y-intercept. So we're starting by putting a point at 0, -4. And then if you recall, slope means rise over run. So I'm going to rise 2 and run 3. Rise 2 and run 3. Rise 2, run 3. And I do that until I can't go any further or I run off the paper. Now I also want to go in the opposite direction. So to get a positive number, a positive slope, we can have a positive over positive, but we could also have a negative divided by a negative, because a negative divided by a negative is positive. So what that means is I'm going to treat the 2 as a negative, going to go down 2, and then I'm also going to treat that 3 as a negative, which means left 3, because a negative divided by a negative is positive, and you can still see it makes that positive slope. Down 2, to the left 3. And we can go one more, down to left 3, and then we connect, making a straight line. And make sure that we put arrows on the end of these. Alright, let's try example 2 together. And that example is y equals -1/3 x plus 6. Again, the m's in the slope, or in this case the average rate of change, is that -1/3. Remember, slope and average rate of change are the same. And then our y-intercept is that 6. So we have to write that as an ordered pair. So it's 0, 6. So then we go ahead and graph this. So we start with our y-intercept of 0, 6. And our average rate of change, or our slope, is -1/3. So that negative applies either to the top or the bottom, but not both, because if it applies to both, a negative divided by a negative is positive. So to start, I'm going to apply that negative to the top, or the numerator. So I'm going to go down 1, which takes care of my negative, and then that means that 3 has to be positive, so I have to go right 3. And then down 1 and right 3. And down 1 and to the right 3. We're then going to go up 1 and to the left 3, because up is positive, but that means left is negative, which gives us a negative slope. Up 1 and left 3, up 1 and left 3. Again, we connect those points with a straight line, put arrows on the end, and we have our line. Okay, try doing examples 3 and 4 on your own, and then we'll check them shortly. Pause the video and try these on your own. Okay, so we're back. Hopefully you got these answers. As you can see, the answers that are up here. For number 3, example 3, just be careful. There's really a 1 in front of the x here. So that means your average rate of change is 1/1, because I can put a 1 underneath anything. And notice there is no b value, so that means that the y-intercept is 0. There is nothing there, so the y-intercept is 0, 0. So I technically started at 0, 0, went up 1/1, up 1, right 1. And then I also had to continue that by going down, which is negative, and left, which is negative. And again, we talked about how a negative divided by a negative still makes that positive slope. And then example 4, we had a slope of -2/1 with a y-intercept of 0, 3, and you can see that graph right there. Okay, we're on to page 4, and that's parallel and perpendicular. And this is where a lot of people had trouble in the pre-assessment. So before you may have been okay, now this is where you want to really pay attention. So first thing we have to notice is that parallel lines have equal slopes, and I know you've talked about that before in both geometry and algebra 1, but just a review. Also, perpendicular lines have negative reciprocal slopes. And again, an example of a negative reciprocal slope would be like -2, and the negative reciprocal of that is 1/2. So not only the negative means you have to change the signs, so this one's negative, this one's positive, but you also have to flip the fraction. So remember, there's really a 1 underneath that -2, and we flip that. So here's an example. It says find the equation of the line through the given point and parallel to the given line. So we have this equation of our line to start, y equals 3x plus 4, and it has to be parallel to this line and go through the point -2, 7. As of right now, this line does not go through the point -2, 7. And we can do that by either plugging in a -2 in for x, or by graphing this line, and you can see that. Let's just graph this line now because we can kind of visualize it. Here would be our y-intercept 0, 4. We go up 3 over 1, up 3 over 1, down 3 left 1, down 3 left 1. Alright, so there's our original line, and as you can see, -2, -7 is down here, and our line does not go through there. So what we need to do is use what we know. We want the line to be parallel. This has a slope of 3. We know parallel lines have the same slope. So therefore our new slope is still going to be 3. This is the point it has to go through, so this is going to be our x, this is going to be our y. The only thing that's going to be different is our y-intercept, because ultimately all we're doing is we're moving this line up or down to make it go through the point -2, 7. So we do not know our b value. So it's just like the problem we did in part 1 here. It's y equals mx plus b because it's a line. We plug 7 in for y. We know our parallel slope has to be the same, so m is 3, -2 is x, and plus b. We go ahead and solve for b by multiplying 3 and -2 and then adding 6 to both sides, and we get that b is equal to 13, making our equation of the line y equals 3x plus 13. So when we graph this line, and I'll do that in blue, it should be parallel to the black line over here and going through the point -2, 7. So let's try it. So first off, y-intercept of 13, that would be up here, and I have a slope of 3. So I'm going to go down 3 and over 1. So that would take me to right here. I'm going to go down 3 and to the left 1. Down 3, left 1. Down 3, left 1, down 3, left 1, and I continue, and I'm going to connect those again. And lo and behold, they do not cross, they are parallel, and right here is our point -2, 7, which the line does go through, so that worked. Now on to the perpendicular. The perpendicular, it's the same line we start with, same point we started with, but now we want to find the equation of the line through the given point that's perpendicular. So we have to recall what perpendicular slopes are. Up above it says it's a negative reciprocal slope. So here our original slope is 3. The negative reciprocal of that would be -1/3. So my perpendicular slope has to be -1/3. Again, this is x, this is y, and it's exactly the same now. I do not know my b, but I have my m, x, and y. So I plug 7 in for the y, negative 1/3 in for my m, negative 2 in for x, and I have to solve for b. So that gives me, once I solve, multiply first and then subtract, I'm going to get b is equal to negative 6 1/3. And again, it needs to be the equation of the line. So my slope is negative 1/3. My y-intercept is 6 1/3. So my equation becomes y equals negative 1/3 x plus 6 1/3. So if I go to graph this now, it should be perpendicular to this original first black line that we graphed and go through the point negative 2, 7. So let's test that out and make sure. I'm going to do that with green. And this is a little tougher because we're at 6 1/3 to start out. So I'm going to start up at 6 1/3, which is right about here. My slope is negative 1/3, so I'm going to go down 1 and over 3. Down 1 to the right 3. I'm also going to go up 1, so up at 7 1/3 now, and to the left 3. Up again to 8 1/3, left 3. And then I connect those. And lo and behold, it's like mathemagic. It crosses through that point negative 2, 7, and it looks like that creates a right angle, which is what the definition of perpendicular is. So it crosses through that point and is perpendicular to our original line, which is exactly what we wanted. Alright, if you've turned to the next page, I want you to try these on your own. Example 1 and example 2. Pause it, try these on your own, and we will get you the answers shortly. Okay, you started it up again. Welcome back. So let's check your answer. We had our equational line, y equals 1/2 x plus 3, and the point negative 4, 2, and we wanted the first line to be parallel. So again, our slope is going to be the same, 1/2, and then our x is negative 4, our y is 2, so we plug that in. Plug all that stuff in. We don't know the b, so that's what we're solving for. We do not know the b. We solve for b, and in this case our b is equal to 4. And then we write our equation, y equals 1/2 x plus 4. And if you graph the original and you graphed the 1/2 x plus 4, you should see that they are parallel and they will never intersect. Okay, so now we have the same equation and same point to start out with, the 1/2 x plus 3, and the same point, negative 4, 2. Now we want it to be perpendicular. So our slope up here is 1/2. Again, perpendicular slopes are negative reciprocals. So we have to switch the sign and flip the fraction. So that means our slope is going to be negative 2. Our perpendicular slope is negative 2. You can put it over 1 if you'd like. And our point, our x's and y's are still the same. So my y is 2, my slope is negative 2, and my x is negative 4. I plug that all in right here. Again, I do not know my b value, so I leave that as b. I'm solving for b, and I get that b equals negative 6. And again, I have to write my equation, so I get y equals negative 2x minus 6. If you graph this one, or when you graph this one on the graph over there, you should see that it is perpendicular to the other ones, meaning it meets it at a right angle. Alright, now's the time to, this video stops and we're going to start part 3, which is the last section.